Good evening, ma. Am I audible? So am I audible, Pa?
Yes, sir.
Okay. So we will start about the metal and non-metals. So yesterday we given the simple introduction about the metal and non-metals. So what are metals? What are non-metals? You could see my screen, right? So metals and non-metals. Actually, see, we are using a number of materials in our day-to-day life. Okay. So very few are available in nature. Rest are available and can be converted from naturally occurring raw material into some usefulness via chemical modification. Some useful substance or some useful material by the chemical modification. So at present we know around 117 elements. Okay, out of which 83 are naturally occurring. So 117 element, about 20 are non-metal, rest are metal. So actually elements are known. That elements, 83 are naturally occurring. And then in that 24 are non-metal. The remaining will become metals. Okay. So what is the metals and what it does with the atmosphere or moisture or air and whatever it is. So we know that what are the physical properties of the metals. What is the physical properties of metals? Usually they have some characteristic physical properties. They are lustrous, metallic lustrous. And then luster means usually shiny. And then have high density. And then ductile. Okay, it can be malleable or it can be converted into wire or sheet. And they have high melting point. And then they are hard and solid at room temperature so they are good conductor of electricity heat and sound. So they have high tensile strength. So it will be the physical properties of metal. Then go to the chemical properties. Usually the metals burn with the oxygen in the presence of air to produce metal oxide. For example, any metal which present with oxygen, it will give metal oxide. So based on the valency, that oxygen will be converted. So for example, the more reactive metal and more violent reaction when it burned with the oxygen. For example, many metals over a period it can be blackened, or metal slowly react with oxygen of air, forming the dull layer of the metal oxide. For example, when the magnesium, it will be ductile metal, so and luster metal. When it combined with oxygen, it will form the dull oxides, magnesium oxide, 2MgO. So this will be the reactive. For example, if you take the sodium and oxygen, it will form the sodium oxide, and they are very reactive. So we are classifying into reactive series. So reactive series la paakumbodhu, reactive series. Number 1. So burn easily with air. Burn very easily with a bright flame, bright flame, and react slowly with air when heated, and then no reactions with oxygen. So it classify example sodium, potassium, sodium, calcium. The magnesiums are very high reactive in the, especially these two alkali metals. These two are alkali metals, and slowly with the metal, aluminum, zinc, iron, lead, and copper. No reactions. Example, gold and silver. Aurum is a gold, argentite is the silver. So they are very, they will not react with the oxygen. This will be the reactive. And other property, இது ஒரு property. Okay, va? We are talk about the chemical property. Other property, usually metal oxides are usually basic, but there are certain metal oxides, both acidic and basic character. They are called as amphoteric oxide. Example on the aluminum oxides. So generally metal oxides are basic. When it hydrolyze, it will give the basic in nature. But certain metal oxide, they will be amphoteric acid. So there are some metal oxide show both acidic and basic behaviors. That means they are ready to react with both acids and bases. These are called amphoteric oxides. For example, Al2O3, aluminum oxide, when react with hydrogen chloride, will give aluminum chloride plus 3H2O. For screen is visible, right? Say yes or no?
Yes, sir.
Okay. When you have aluminum oxide, it react with sodium hydroxide. It will give NaAlO2 plus 3H2O. So this is known as, so look here, the first case it react with HCl, so it become basic in nature. The second case it react with base, it become acidic nature. So they are called acidic oxide. In addition to aluminum metal, zinc, tin, lead, and beryllium can also be form amphoteric acid. So what are the things which form the amphoteric acid? So amphoteric oxide will be formed by metal zinc, tin, lead, and beryllium. This also will form the amphoteric oxide. Okay. And the next, most metal oxides are insoluble in water. Okay, but some of these are dissolved in water to form alkali sodium oxide and potassium oxide dissolved in water to produce alkali. For example, Na2O plus H2O, it gives 2NaOH. And then K2O plus H2O, it gives 2KOH. Examples. Okay. And then reaction of metal with the water. So metal react with water and produce metal oxide and hydrogen gas. This is the one of the test for the acid. So the metals. Metal react the water, it will give the hydrogen gas out. Okay. Example. Reactive metal only can react with the cold water. The other metals will not react with the water. That also you should remember. Okay. In the potassium, react with water, it will give potassium hydroxide plus hydrogen plus heat. Is a violation. Okay. Potassium hydroxide. So when you are balancing, it becomes 2KOH and then it becomes 2H. And then 2 sodium plus 2H2O. It gives 2NaOH plus H2 plus heat. Okay. The reaction of calcium with water is less violent. Okay. But reaction with potassium and sodium is more violent. நல்ல சத்தம் கிடைக்கும் தம்முன்னு அடிக்கும் அடுத்து. And the calcium treated with water, it will give calcium hydroxide plus hydrogen gas. Okay, this will be one of the reaction. So the other metal, look that aluminum, zinc, iron, lead, copper. So when the acid react with metal, it forms salt and hydrogen produced. For example, when the metal like copper, it react with H2SO4, it will form copper sulfate plus H2. So that salt is produced depend upon the acid and metal reacting. Generally, sodium, potassium, lithium, and calcium react violently with the dilute sulfuric acid and dilute hydrochloric acid. So when you are treating sodium or potassium or lithium or calcium, okay, with dilute H2SO4 or dilute HCl, it will give that, it will evolve hydrogen with the violent. So they are exothermic because it give the heat away. Okay. And then the reactive series. Reactivity. Magnesium, aluminum, zinc, and iron. Okay. So in case of copper, no bubbles were seen and the temperature also remain unchanged. So that shows that copper does not react with dilute HCl. Okay. அடுத்து reaction with metal with the nitric acid. And the copper treated with HNO3 and then 2H plus, it gives copper 2 plus and 2NO2 plus 2H2. Okay. So the dilute nitric acid added to zinc, aluminum, and copper. Zinc or aluminum and copper. They immediately thereafter zinc and aluminum show no reaction. But the copper slowly it produce NO2. So aluminum, zinc do not react with concentrated nitric acid because it is hard to dissolve the oxidation of layer belts. ஏன்னா அது மேல என்ன இருக்குன்னா ஆக்சைடு ஃபார்ம் ஆயிடும். ஒன்ஸ் த ஆக்சைடு ஃபார்ம் ஆச்சுன்னா passive oxidation, it will not further reaction. Okay, இது ஒரு reaction. So there are certain metals which replace the other one. A metal will displace the less reactive metal in the solution. For example, if you take the copper sulfate, that will be blue in color. When you treat with the iron, so the resulting solution will be light green color. That due to presence of iron sulfate and then result copper. So what it means, iron is more reactive than copper. Okay, iron is more reactive than copper. The same iron with magnesium sulfate, no reaction. What is the meaning? What is the meaning? What is the meaning? First one, the iron is replaced the copper, it gives the iron sulfate. Second one, iron is not replacing the magnesium, so no reaction. What it mean? What it mean, Pa? What it mean? See, anyone can answer, no? Here, the iron is replace the copper, so iron is more reactive than copper. Here, iron plus magnesium sulfate, no reaction. Then what it mean? What it mean?
Sir,
Ah,
sir, magnesium is more reactive than iron, sir.
very good. That's all. This is what the question asking in that thinking part. So the reactive series. The arrangement of metal in the decreasing order of their activity is known as activity series or electrochemical series. It is also known as reactive series. So reactivity series of metal. So we can classify into three types. So they are classifying based on the hydrogen. Okay. So number one, potassium is the most reactive metal, and then sodium, calcium, magnesium, aluminum, zinc, iron, tin, and lead. And then hydrogen. After that, copper, mercury, gold, and silver and gold. So look here. So the blue color, whatever I'm written, no, that is metal more reactive than hydrogen. So they are more reactive than hydrogen. More reactive than hydrogen. So most reactive metal. They are most, which is most reactive metal? Potassium is the most reactive metal. Which is the least reactive metal? So they are less reactive than the hydrogen. So this one is known as least reactive metal. So that metal can be occur in the earth crust is a very big source for the metal. Okay. So metal can be occur in the nature, sometimes free, but most of the time it combined state. So metal like silver, gold, platinum, they are occur in the free or native state, but most of the metal found in the form of compounds in the nature. So they need to be separate from the impurities. So for the various applications, for example, if we gold enamel pandrona, that reason we have to separate the gold. Okay. So the process of extraction of metal from the various purpose is called as metallurgy. These naturally occurring compound of metal are known as minerals. Okay. So first one, minerals. Minerals. What is minerals? Naturally occurring compounds of metal are known as minerals. Known as minerals. Then the second one, ores. What are ores? See, ores are those minerals which metal can be obtained economically and profitably. Therefore, all ores are minerals, but all minerals are not ores. So, ores are those minerals from which metals can be obtained economically and profitably. Okay. So what is the conclusion? All ores are minerals, but all minerals are not ores. Okay. அடுத்து matrix or gang. Unwanted, rocky, earthy, or sandy materials almost or always associated with ores as impurity are called gangue or matrix. So if you take many metals which can occur their ores as in the form of oxide, as in the form of carbonate, as in the form of sulfide, as in the form of chloride, halides. Okay. So now some of the material we can see that. So types of ores. Types of ores. So again, we are classifying first one as oxides. Many material which can be obtained as a oxide. For example, aluminium. It will be available as a bauxite. So bauxite is nothing but Al2O3 and 2H2O. And iron, which is obtained as hematite, which is Fe2O3. And then another thing, magnetite, that is also iron ore. It's a sulfide oxide ore, Fe3O4. Okay. And then zinc, it will be zincite and Z10O. Then copper, cuprite, Cu2O. And then lead, litharge, it's become PbO. Okay, these are the oxide ores. So when you go to the carbonate ores, the magnesium which is obtained as a malachite. Oh, sorry. Magnesium which obtained as a magnesite. So that is nothing but MgCO3. And then calcium which is obtained as a limestone, Sunambakal, calcium carbonate. And then copper, which is obtained as a malachite. So that malachite green, this copper carbonate along with copper hydroxide, it becomes the deep green color. So they known as malachite green. Okay, these are the carbonate. And then sulfide ores. Oxide na oxygen, carbonate na carbonate, sulfide na S2. In this sulfide ores, first mercury, it's available as a cinnabar. And then copper and iron, so zinc blend, ZnS, HGS. So this will be the copper and iron, which is available as chalcoprite, CuFeS2. And then halide. That halide, chloride or fluoride or it may be chloride or fluoride. So இதுக்கு வந்து இன்னொரு சல்ஃபைடு காப்பருக்கு இருக்கு. காப்பருக்கு வந்து chalcosite. அது வந்து Cu2S. For the halide, first one common salt. Common salt என்னது? Salt water, sea water, salt. Sodium chloride, it's a source for sodium. Next, calcium. Calcium will be fluorospar. Calcium fluoride. And then silver, it's a horn silver. It's AgCl. So these are the various type. So from this we can extract the metal, whatever I'm writing the first one, the extractable metal. The second one, so there are types of ore which are obtained in the earth as oxide, carbonate, sulfide and halide. From this we can extract that material. That's why they are called as ores. So extraction of metal on the basis of reactive series. So what are the reactive series is there? Low reactive, moderate reactive and highly reactive. So based on that we have to follow certain metallurgy. என்னன்னு பாருங்க. Extraction of metals on the basis of reactive series. Okay, so first one, extracting metal low in the active series. So generally என்ன பண்ணுவாங்கன்னா, they will take the metal, they will use heating, they will convert it into oxide, and that oxide they will convert it into corresponding metal by the reduction. Second one, the middle active series metal is there, no, that they will do calcination or roasting. Active series they will do the electrolysis. This is the way by which they are doing separating metals from the ores. Extraction of metals. So metals வந்துட்டு we are classifying into three types. Highly reactive metals, which can be which can be separated by using electrolysis of molten ores, and then purification of metal, and then pure metal. This is the way by which. And the second one, more medium reactivity. So first, what is the step taken now? That will be, so based on the medium reactive metal, whether it will be a carbonate ore or sulfide ore. If the carbonate ores, it can be calcination. So calcination is nothing but, what is calcination? What is calcination, ma? Calcination, you have to, the ore is heated to a high temperature in the absence of air. So calcination, heating of ore, absence of oxygen. So the sulfide air, or it will be roasted. Roasting. Roasting is nothing but in the presence of ore. So heat with oxygen. Heat without oxygen. That is the difference. Okay. And then both will undergo oxides of, give the oxide of metal. That metal you have to reduce. Reduction. And then reduction, you have to go for the purification. And purification will get the pure metal. Suppose we are having low reactive metal. Low reactive metals, it has sulfide ore. Sulfide ore means what we have to do? Roasting. What is roasting? Heating with oxygen. And then it will give the metal that will be going for purification. And then it will give the pure metal. So this is the way by which we can do that purification. Is it clear for all of you? Any doubts? Any doubts?
No, sir.
No, sir.
So this is the way we have to do that. Electrolysis means what? So at anode and cathode, two things will be. The metal, sodium, magnesium, calcium, aluminum are highly reactive, no? That will be taken for the electrolysis. So the reactive series are very reactive and cannot be obtained there pure from their compound by heating with a carbon. So such metals can be obtained by the electrolytic reduction or fused sodium chloride in the down cells. So what they will do now, at cathode, at cathode, the sodium gain the electron, it becomes sodium. At the anode, the chloride, it converted into chlorine gas, it lose the electron. So generally, reduction, oxidation. உங்களுக்கு எப்பவுமே வந்து ஆனோட்ல என்ன நடக்கும், கேத்தோட்ல என்ன நடக்கும் தெரியல அப்படின்னு சொன்னா, ஜஸ்ட் யூ ரைட் ரிடக்ஷன் ஆக்சிடேஷன். இதுல ரெண்டுமே காமனா இருக்க டேர்ம்ஸ் என்ன, TiON, TiON. அதுக்கு முன்னாடி என்ன இருக்குன்னு பாருங்க. So the reduction occur at cathode, oxidation occur at anode. What is oxidation? Loss of electron oxidation. What is reduction? Gain of electron reduction. சரி ஆயிடுச்சா? எல்லாம் கம்ப்ளீட் ஆயிடுச்சா? இது கிளியர்? Is it clear, pa?
Yes, sir.
So these are the points which we have to remember in the electrolysis and purification of metals, that and all. ஓகே, இப்போ நீங்க உங்க டவுட்ஸ் கேளுங்க. Doubts இருக்கா? So now I'll write some of the examples. You have to answer for that. So இது ஒரு match the following. Match. So first column-ல இது second column. Number 1 iron. So இதுல A-ங்கிறது என்னன்னா liquid at room temperature. Number 2 it's a copper. அது B என்னன்னா deposition of reddish brown layer on exposure to moisture. Number 3 potassium can be cut easily with knife. And 4 it's a mercury. Formation of greenish layer on exposure to moisture. So tell me, for iron, which is the correct one?
So for Fe, deposition of reddish brown layer on exposed to moist air.
For copper,
For melting greenish layer on exposure to moisture.
formation of melting layer. And what about potassium?
Sir, can be cut easily.
Can be cut easily. And what about mercury?
Liquid
Yeah.
at room temperature.
Very good. Next question. An element, question எழுதுறேன். An element X, the atomic number 12, reacts with another element Y, atomic number 17, to form a compound Z. Which of the following statements are true regarding this compound? So statement போடுறேன், which is the correct statement? Which is or which of the following statements are true regarding this compound? 1. The molecular formula of Z is XY2. And number 2, it is soluble in water. Number 3, X and Y are joined by sharing of electrons. Number 4, it would conduct electricity in the molten state. You tell me, Pa, which is correct? So options they were given. A வந்துட்டு 2 and 3. B வந்துட்டு 1 and 3. C வந்துட்டு 1, 3, 4. D வந்துட்டு 1 and 4. இதுல எது? எதுமா ஆன்சர்? அட்டாமிக் நம்பர் 12ங்கிற நான் இது வேணா சொல்றேன், எலமெண்ட் வேணா சொல்றேன். 17ங்கிறது குளோரின், 12ங்கிறது தெரியுமா?
Sir, magnesium.
மெக்னீசியம். ஸோ திங்க் ஆஃப், அப்ப இசட்ங்கிறது என்ன எலமெண்ட், என்ன காம்பவுண்ட்? மெக்னீசியம் மோனோவேலண்டா டைவேலண்டா? ம்
2 and 3.
2 and 3 ராங்.
Sir, 1, 3, 4.
1, 3, 4 wrong.
Sir, 1 and 3.
Wrong.
So 1 and 4.
See, that magnesium will form magnesium chloride, right? So this will be correct. So 1 will be the answer. Apo automatically A is ruled out, right? It's soluble in water because the magnesium chlorides are not that much soluble in water, but they are joined by sharing of electron. So transferring of electron தான் இருந்தது இல்லையா, மியூச்சுவல் ஷேரிங் கிடையாது, கோவலன்ட் கிடையாது. அப்போ 3 கிடையாது. So it would conduct electricity in the molten state, correct. அதனால 1 and 4. எல்லாரும் என்ன பண்ணுங்க, you do one thing. So now I give some question that you answer and you connect in the next class. Simplest question. Zinc plus HCl gives what? And then sodium plus H2O, it gives what? And then MnO2 plus Al gives what? And copper sulfate plus iron gives what? And iron sulfate plus zinc gives what? இந்த 5 கொஸ்டினுக்கு மட்டும் ஆன்சர் எழுது. கொஸ்டின் நோட் பண்ணிக்கோங்க. To write the answer. எழுதிட்டீங்களா கொஸ்டின்? கொஸ்டின் எழுதியாச்சாமா?
Yes, sir.
Then you can leave. You write the answer and give it to Bhaskar sir. I will connect at the Monday. சரியா?
Okay, sir.
Okay. Bye.